Welcome everyone. So today we are doing worksheets on 2D trigonometry. This one is for 2D trigonometry, and for 3D trigonometry we will be doing the different worksheet. The theory we have already covered, and now we are doing the practice. So see the first question. Clearly you can see it's a right angle triangle, and here they are asking you to calculate theta. So what if you remember my theory video, I have mentioned that you have to specify first which one is opposite, which one is adjacent, which one is hypotenuse. So we just need to label it. Obviously the angle is this. So the side opposite to this angle is going to be opposite. Side which is connected to this one is your adjacent. And this is 90 degrees, side opposite to 90 degrees always hypotenuse. So this is the best way to mark it. Now because adjacent and opposite are given to us, so we just need to see that which trigonometric ratio connects both, and it's definitely tan theta. So tan theta is equals to opposite over adjacent. Opposite is 12, adjacent is 9. So theta is tan inverse 12 over 9. Using calculator, we'll get answer as 53.26. Moving on to the next question. Question 2 says calculate AD. That means this whole length AD you have to calculate. So as I told you, if you see any question which is a combination of two different triangles, you have to take triangles one by one, and we always start with that triangle in which you will see the maximum known perimeters. So that means if I name it one triangle and triangle 2, clearly I can see in triangle 1 I can see more perimeters, because in triangle 1 I have AC as well as angle also given. So with the help of this I'll calculate BC. Now question is why I am calculating BC? See, as of now I am not sure that I have to calculate BC or not, but if you remember my previous video, I have described you if a figure is made up of two triangles, we'll try to find that value that side which shares the same. That means BC is that size that is shared by both the triangles. So I'm just finding the common side at this point of time. So taking the triangle 1, that is triangle A, B and C, I need to calculate BC. Again, what I'll do opposite, hypotenuse and adjacent, labeling them. So side opposite to this angle is opposite. Side that is connected with this angle is adjacent. If I want to calculate opposite, I have adjacent, I need tan theta. So in triangle ABC, I need to apply tan 30 degrees, which is opposite over adjacent. Opposite is BC over adjacent is 8. On cross multiplying, tan theta is 1 over root 3. 1 over root 3 multiplied by 8 is equals to BC. So finally BC is equals to 8 over root 3. We know the common side obviously. Now I have to take triangle BCD. So in triangle BCD, this opposite is now known to us. We have one angle, we can calculate CD. Why I am calculating CD? Because ultimately I need AD. So for whole AD, I have AC, only CD is required. So in triangle BCD, same thing, again labeling opposite and adjacent. So the side which is connected with 50 degrees is adjacent. Side opposite to 50 degrees is opposite. That means BC is still opposite to it. So in triangle BCD, applying tan 50 degrees. Opposite is BC because this side is opposite to the angle. Adjacent is connected with the 50 degrees. So this is over CD, which is we have to calculate. Now putting the value of tan 50 and BC, will get answer as, on rearranging, I'll get CD as BC over tan 50 degrees. So BC is 8 over root 3 over tan 50. On solving, I'll get CD as 3.87. If CD is 3.87, AC is 8, AD is what? If you see, this whole AD is a combination of AC plus CD. AC plus CD. AC is 8, CD is 3.87. So your final answer is 11.87 centimeters. So this is the distance between A and D. See this question. It says triangle ADB here, and it's a combination of two different triangles, which is ACB is also incorporated in it. We need to calculate the length DC. DC, that means this is specific length. This gave me a clear indication that if I can calculate the whole length DB with the help of bigger triangle and calculated the length CB with the help of a smaller triangle, on subtracting the both, I can get the answer. So, I need to start with my smaller triangle. That means in triangle ACB. If I apply the trigonometric ratio, again I'll be saying I have to mark it which one is opposite, which one is hypotenuse. Clearly, if this is the angle, so adjacent is the angle that is the side that is connected with this angle. So this is your adjacent, and obviously this one is your opposite. So I have to calculate CB. Ultimately, if I want to calculate DC, I should know the CB. So vertical height is required, opposite is required. I'll apply tan theta. So tan 20 degrees is equals to opposite, which is CB, over adjacent, which is 12. So CB is 12 times tan 20 degrees. This will give me answer as 4.36. Now, or we can say 4.37 up to 2 decimal place. Now we need to calculate the bigger one. How can we calculate the bigger one? For this, we have this whole, this DAB. This one is actually 60 degrees. Okay. So now we have to apply in a bigger triangle. That means taking triangle ADB. So in triangle ADB, I have to apply same. That means this whole is opposite because this is opposite to the angle 60 degrees. And the line or the side that is connected with 60 degrees, your adjacent, which is still your 12 meter. Applying tan 60 is opposite, which is DB, over adjacent, which is AB. So DB is tan 60 into AB. AB is 12. Tan 60 is root 3. So root 3 into 12, which will give our answer as 20.78. If this whole is 20.78 and up till here it's 4.37, so this one remaining is definitely 20.78 minus 4.37. So finally I can say length DC is equals to 20.78 minus 4.37, which will give us answer as 16.4 meters. Moving on to the next question. Question 4 says a man is standing at B. That means the man is standing here at B. The angle of elevation of the top of the tower is 60 degrees. See, angle of elevation, that means if you're looking something up there, that is your angle of elevation. If you are looking something down below, that is your angle of depression. Because the man is looking at the top of this tower, so definitely the angle of elevation we will mention, which is at 60 degrees. After walking some meters away from his initial position is where he was standing initially, which was B. He walked some meters away, like this, meters away, and now he is at point A. At point A, the angle of elevation is 30 degrees. On this diagram, we can see that as well. If the height of the tower is 10 meters, find the distance that man has moved. If this height is 10 meters, we have to calculate the distance that he moved. Again, this figure is a combination of two triangles. Actually, it's a combination of three triangles. But since we are applying trigonometric ratios, that means we are looking for the 90-degree triangle. So here we have two 90 degrees triangle where we can apply trigonometric ratio. What we can do, we have to calculate AB. So it gave me a clear idea that if I can calculate length of AC and then length of BC, subtracting them will give me AB. It's just like the previous one. The only difference is previous one was dealing with the vertical height. Here is the horizontal distance. So I'm taking the smaller triangle, and obviously I'll pick that triangle in which I have the maximum known variable. Though in both the triangles we have the same kind of it, so I can pick any one. But let me start with the smaller one, which is DBC. So tan 60 degrees, applying in DBC. Tan 60 is opposite. Again, the side opposite to the angle is opposite. Side connected with the angle is adjacent. So tan 60 is 10 over BC. So from here BC is equals to 10 over tan 60 degrees. This will give me answer as 5.77 meters. Now applying same in the bigger triangle, that is in triangle DAC. Tan 30 is equals to opposite DC over adjacent. Why AC is adjacent? Because it's connected with the angle 30 degrees. So AC will be, on rearranging, I'll get DC over tan 30. If you're thinking how I got this one, so it says first cross multiply. It gave me AC tan 30 is equals to DC. Now dividing both the sides by AC, you will get tan 30 is equals to AC over DC. DC over AC. That's how I got this. So, or if you want to calculate AC, this will be DC over tan 30. So, we got this one. So, it's just about simple cross multiplication, how we solve any fractional algebraic function. So, DC is given as 10. So, AC is 10 over tan 30 degrees. So, AC is 17.32. Finally, we have to calculate AB. So, AB is clearly AC minus BC. AC we have calculated as 17.32 and BC is 5.77. On subtracting, we'll get 11.55 meters. So, this is the distance between A and B, or we can say the distance that man has moved. Moving on to the next question. Question 5 says calculate the area of the given figure, and again it's a combination of two different triangles. So we have to calculate the area of each triangle, add them up will give us the area of this given figure. So we have two different triangles. Let I name it, because in this initial figure there is no naming, but we are labeling it. Let me say A, B, C, D and E. So I am taking triangle ABC first, and here triangle ADE. To calculate the area, I should know half times base times height. That means for both the triangles, I should know base and height. Base is what? Your adjacent. Let me focus on triangle ABC. For triangle ABC, I should know the base, which is adjacent, as well as height, which is opposite. But for this triangle, only one thing is known, that is angle. So we can't initiate our process from this triangle. Instead, we have to initiate from triangle EAD. Even I told you before as well that we always start with that triangle whose maximum parameters are known. Obviously, maximum parameter is for EAD because we know one angle as well as one side. Applying the trigonometric function here, first I need to label the side opposite to it is opposite. So opposite to angle is this one is opposite, and this one is the side opposite to 90 degrees hypotenuse. That means remaining is adjacent. Clearly calculating ED will give me nothing. Neither it will help me in calculating the triangle area, as well as it will not help me in finding the other side, because apart from finding the adjacent, for the area of the triangle, it's also going to help me to calculate the other side, the side that is shared by both the triangles. So applying tan theta, because tan theta connects opposite and adjacent. So tan 30 degrees is opposite tan, adjacent is AD. Same on rearranging. In just previous question I have described how I rearranged it. Similarly, doing it, I'll get AD is equals to 10 over 10 30 degrees. And we just saw 10 over 10 30, it was 17.32. So 17.32. AD length is 17.32. I can calculate area. Area is half times base here AD. If you see this triangle in this way, clearly your base is AD. So half times base AD, that is 17.32, into height, that is 10. Answer is 86.6 centimeters squared. Now I need to calculate for ABC. We just saw at the beginning of this question that only one perimeter of ABC is known, which is the angle. But now we have hypotenuse as well. How? Because we have calculated AD. AD to be 17.32. And DC is already mentioned as 2. So I have this whole AC. AC is what? 17.32 plus the 2 centimeters, which is already given in the question, give me 19.32 centimeters. If I focus on this triangle only ABC, I have one angle and hypotenuse. What I need? I need to calculate base and height, that is opposite and adjacent both. So let me apply both trigonometric functions one by one. That means if this is my angle, side opposite to this angle is opposite, side connected to this side is adjacent. So applying sine theta, so sine 40 is opposite, which is BC, over hypotenuse. Hypotenuse is AC that we just calculated, 19.32. So BC is sine 40 into 19.32. Similarly, I can calculate adjacent, which is AB, by applying cos theta. So cos 40 degrees is adjacent AB over hypotenuse, that is 19.32. AB is cos 40 degrees. On cross multiplying, I'll get AB is equals to cos 40 into 19.32. So BC is 12.41 and this one will give me 14.79 or 14.8. We now have adjacent as well as opposite. That means base and height I have both. I can calculate the area of this triangle ABC, which is half times base is we calculated as 14.79, or I can say 14.8 into height, which is 12.41. This will give me 142.968. We need to calculate the area of this whole figure. That means adding up the both areas. So 86.6 plus 142.968 will give 229.56. 229.568 or 57 centimeters squared is the required area. Okay, see this question 6. It says in the given figure O is the center. Point A and B are 2, minus 10 and 2, 5. That means they are the endpoints of the diameter and we have to calculate the length of AC. This length we have to calculate. Clearly we have to use some properties of the circle as well as we need to use the circle theorem. If you are aware of that, it would be easier for you to calculate. And if you're not aware or if you're not in a touch with the circle theorem, I'll be discussing like the needed circle theorem or the properties here. The property that is required here is AB is a diameter. So angle subtended by the diameter is always 90 degrees. So that means this is always 90 degrees. If AB is given its diameter, why AB is given diameter? Because O is the center. So line passes through the center is always your diameter. So angle subtended by the diameter in a circle is always 90 degrees, which clearly gave me an idea that triangle ABC is a right triangle. And right triangle at C. So angle ACB is equals to 90 degrees by circle theorem, and I am just defining the circle theorem. Angle subtended in a semicircle is always 90 degrees. Moving on to the another part. This can help us clearly. Why? Because if I can calculate the length of AB, this whole is a 90-degree triangle, it will help me. I can apply trigonometric ratio, but at least I should know either I can apply Pythagoras theorem, so for that I should know BC, which seems a bit difficult for me. But as angles are mentioned here, this angle is also mentioned, that means I can calculate the other angle and can apply the trigonometric ratio. Then we have to calculate the length of AB. X and X is same, only it's moving in Y direction. Definitely if it's in moving direction, it should be like vertical, but they have given the coordinates like this. So that means the distance between these two is clearly minus 10 to 5, which is 15. If you move from minus 10 to 5, how many units or how many uh, distance you are moving? It's 15. So the distance is 15. I get to know that AB is 15 units. Why I'm saying units? Because nothing is mentioned. The centimeter, millimeter, nothing is mentioned here. So that's why I'm saying 15 unit. Unit can be any unit. Centimeters, meters. Next is we have to calculate angle. Any angle will work. This angle also will help. This angle will also help. Any angle will help. So let me start with the one whose value is given. That means look out the triangle OCB. OCB. We have 70 degrees there. And one more thing is an isosceles triangle. Why this is an isosceles triangle? Because OC is equals to OB is the radius. The distance between any point on the circumference of a circle to the center. The distance between these 2 points is always radius. So distance from center to one point on the circumference and distance between center to another point on the circumference, these two are equal because they both are radius, which gave me an idea that OBC is an isosceles triangle. That means angle CBO is equals to angle OCB. As this side and this side are equal, this angle and this angle will also be equal. This is a property of isosceles triangle, which says opposite side of equal sides of an isosceles triangle are equal. I can say therefore angle, these two are equal. Okay, which means if I say this is x and this be x, on applying angle sum property in this triangle, so I can say x plus 70 should be equals to 180 degrees. From here I can say x is equals to 55 degrees. If each one is of 55 degrees, I need nothing more. Why? Coming back to the bigger triangle, in triangle I'm just writing just near to this diagram. In triangle ABC, now if I delete this all things that I have made so that you can get a better idea, this we have calculated as 50 degrees. Our main focus is this triangle, this one, this triangle. In this triangle, this is 90 degrees, This is 55. I can apply trigonometric ratio easily. Now I need to label. The side opposite to the 90-degree is always your hypotenuse. This is why at the beginning I have described you how to label hypotenuse, adjacent and opposite. Because if the triangles are like upside down or diagonal, then it would create a confusion. So in that case, you would be aware that what is hypotenuse, what is adjacent, what is uh, opposite. So this is your 90-degree angle. So side opposite to 90 degrees is always hypotenuse. That means AB is hypotenuse. So I can write AB as hypotenuse. Side opposite to angle given is the side opposite to 55 is AC. So AC is opposite. We have to calculate opposite and we have hypotenuse. That means which one I have to apply? I have to apply sine. So sine 55 is opposite, which is AC, over hypotenuse, which is AB, that is 15. So AC, because ultimately we have to calculate the length of AC, we are just almost there. AC is 15 times sine 55, which give me 12.287 or 12.29 units is the length of AC. Moving on to the next question. Next question is also definitely you can see it's a circle. So obviously it will deal with the circle theorem and the properties. Let me read the questions. In the given figure, ABCD is a cyclic quadrilateral. Cyclic quadrilateral is a quadrilateral that is described in a circle and its every vertices lie on the circumference of a circle. Mostly what I have seen, though that I will describe in a circle theorem as well, I am describing it here as well. If suppose this is a point and this is a quadrilateral, student think that this is also a cyclic quadrilateral. 3 points are lying on this circle, fourth is not lying. For a cyclic quadrilateral, all the points should lie on the circumference of a circle. Here you can see A, B, C, D, all are lying. Angle BAD, that means this angle is given as 110 degrees. EDC, that means this angle is 40 degrees. And ECB with this angle, this is smaller angle, is 20 degrees. Length DB is 17, this length is given as 17 centimeters. Then find the length of DC. Which length we have to calculate? This length. If we have to calculate this length, obviously our main focus is the triangle. There are two different triangles of which DC is a part. The triangle BDC as well as triangle DEC. It's a part of both the triangles. If it's a part of both the triangles, I need to see which triangle will help me. So I'll start with the one whose maximum things are known. But for both the triangles, I couldn't find anything. But at least we can use one property, which is a cyclic quadrilateral property, so that I can get the value of this whole angle. This angle. A cyclic quadrilateral, in a cyclic quadrilateral, opposite angles add up to 180 degrees. So I can say that, let me write it down. Angle BAD plus angle BCD is equals to 180 degrees. Because opposite angles in a cyclic quadrilateral add up to 180 degrees. So now I can say if angle BAD is 110, so angle BCD is definitely 180 minus 110, which is 70 degrees. So this whole is 70 degrees. Okay, now which one I have more? Clearly, I have the triangle DBC. In triangle DBC, I know one angle as well as I know one side. But the thing is, if you think that okay, I can apply trigonometric ratio, you can't at all, because nothing, no triangle is a right angle triangle. It's mentioned none where. If it would be ABC is a rectangle, then obviously other side would be 90 degrees. We wouldn't be doing finding the angles. But one is 110, 70, which is clearly it's not a rectangle, no right angle involved. That means we have to go for either sine rule or cosine rule to calculate DC. Whether I'm applying sine rule or cosine rule, at least I should know another angle or side. In triangle DBC, we have one side, we have one angle. We need to find the other angle or other side. So let me use the smaller triangle DCE. Maybe that will help. See, in triangle DEC, we have 40 degrees. I'm just focusing on this triangle only and just overlapping the edges, the sides, so that we can focus only on this maroon triangle, triangle DEC. 70 degree was this angle and 20 is already mentioned. That means the whole angle ECD. If you are still confused that why whole angle ECD is 70 plus 20, because 70 we just calculated. We haven't calculated whole ECD. Whole ECDs are not a part of cyclic quadrilateral. Angle BCD is 70 degrees. Angle BCD, see, you know how to read the angle. So you can clearly see angle BCD is 70 degrees because that's the angle opposite, or that's the angle which is a part of a cyclic quadrilateral. Now we have calculated 70. 20 is already given. So whole angle ECD will be 70 plus 20, which is 90 degrees. Okay, if this is 90 degrees, now even we need not to bother about sine rule, cosine rule. I can directly apply here trigonometric function. If it comes out to be 110 degrees or other than 90 degrees, then we have to go for sine cosine rule. But as we already know that this is 90 degrees, so need not to bother about anything. We can directly apply trigonometric function in triangle DEC to calculate the length of DC. Now, if this is whole 90 degrees, this is 40, we should know, okay, but there is a catch. The catch is that we don't know the length of any other side, so we can't calculate DC. At least we should know DE or EC, at least we should know that. So let me just skip this plan as of now. In my mind there's another thing, which is calculating the third angle. I know it's difficult that to know where to proceed, and same thing I'm doing here, right? We have started, I always told you, start with the reverse order. Whatever be the question given, start from there, and then you will keep on getting the different ways to calculate your right answer. And same thing I'm doing it here now, because when I saw 90 degree, the first thing that popped up in my mind was, okay, I can apply trigonometric function. But then I saw that I have no side given, I can't do anything. So only possible thing remaining for me is to calculate the angle. That's all I can do here as of now. So I'm just calculating the third angle, the angle which is angle DEC. Angle DEC is equals to 90 plus 40 subtract 180. Angle sum property, simple. Or at all the angles, it should be equals to 180 degrees. So angle DEC will come out as 50 degrees. This is 50 degrees. Now let me just delete this whole thing. This is 50 degrees. Now I need to see what else I can do. I need something. I'm done with it because I know all the angles, no side involvement. So neither sine rule nor cosine rule, nothing is gonna help me. So that means I need to shift to the other triangle, that is DB. Here it was C. DBC, I need to shift my whole focus on this one. But again, I have only one side and one angle 70 degrees. I don't know the other angle. Obviously, there comes the help. There comes the role of 50 degree that we have calculated. This angle will also be 50 degree, and that is by circle theorem. So circle theorem says the angle subtended by an arc on the circumference or at any part of the circumference of a circle is always equal. So angle subtended by an arc, that means this angle subtended by BC. This BC subtending means making. This angle, this arc BC is making this angle at E, which is a point on the circumference. If it's the same arc is making an angle at another point on the circumference, the both angles should be equal to each other. If it's still unclear to those who haven't done the circle theorem, I'll be doing circle theorem in coming days, so you can do there and then come back to this question. So these two are 50 degrees. So I can say angle DBC is equals to angle DEC is equals to 50 degrees, because angle subtended by the arc, by an arc at any point on circumference is equal. So that means it's gonna be 50 degrees. I have now two angles, one side. Okay, I can apply sine rule. We studied sine rule yesterday. I have explained you if you have two angles, one side, and in this condition we go for sine rule. So sine rule says, now only focusing on this triangle, let me overlap it. Focusing on triangle DBC. So in triangle DBC, applying sine rule, so sine of angle 50 over the side which is opposite to it. So sine of angle 50 over DC, sine of angle 50 over DC is equals to side which is given, that is DB, and angle, that is sine of angle 70 over the opposite side. So sine of angle 70 over opposite side, that is 17 mentioned here. Only rearrange it and get the answer. I'm just cross multiplying it. It will give me sine 17 times sine 50 is equals to DC times sine 70. Dividing both the sides by sine 70, I'll get DC is equals to 17 into sine 50 over sine 70. This will give me answer as 13.86 centimeters. So this is the length of DC that is they are asking you to calculate. Moving on to our last question, which is question number 8. Question 8 says, ABC is a triangular park. A man is standing at A. So man is standing at A. He took 20 minutes to reach from A to B while moving with a speed of 1.2 meters per second. That means the time and the speed is given, we can easily calculate distance. How? Because the speed is equals to distance over time. So on rearranging, distance will be speed into time. We can do like this. Similarly, maintaining the same speed, it took him 30 minutes to reach from B to C. Calculate the time taken by man to reach from C to A if he walks with 1.5 meters per second. So while moving with a speed of 1.2, so let me calculate the distance of AB first. So distance is 20 minutes is a time. Let me convert it into second because speed is in meters per second. So 20 into 60 into 1.2. That will give me answer as. So it will be 1440 meters. So now we know 1440 as the distance between AB. Similarly, we have to calculate the distance from B to C. It says maintaining the same speed. That means still the speed is 1.2 meters per second. It took him 30 minutes to reach from B to C. That means 30 minutes from B to C is distance same, speed is 1.2. It's 30 into 60. Why I am multiplying it with 60? Because in order to convert meters into seconds. Finally, it will give me B to C as here, A to B as this is 2160 meters. So this is 2160 meters. Now they are asking you calculate the time taken by a man to reach from C to A if he walks with 1.5 meters per second. They are asking you to calculate the time. We can calculate the distance easily, and then we have the speed to calculate the time. So if we have two sides and a non-included angle, we always go for sine rule. So on applying sine rule, I will say AB over sine of angle 40 or sine of angle 40 degrees over length AB, that is 1440, is equals to BC, and the angle opposite to this is this angle. So that is angle A. So sine of angle A over length is 2160. From here I can calculate sine of angle A. So sine of angle A is sine 40 into 2160 over 1440. This will give me, this is 0.964. So angle A is equals to sine of inverse 0.964. This will give you ultimately 74.56 as the angle. So angle A is 74.56. See why I am calculating this angle? Because I need to calculate AC ultimately. So for AC I need angle B. So both the sides, that means an angle and opposite side, both are unknown. So for that I need to calculate other angles, so that by applying angle sum property I can calculate this one. So we know that sum of all the angles in a triangle is 180 degrees. So from here I can calculate this to be 65.42. Now I can easily apply my sine rule, because I know one angle, that is sine of angle B is 65.42. So here I can write sine 40 over 1440, same thing I'm taking, is equals to sine of 65.42 over the side that we have to calculate, that is AC. On cross multiplying, I'll get AC as sine 65.42 into 1440 over sine 40 degrees. On solving, I'll get answer as 2037.23. This is your distance meter. So length of AC is, or he walked 2037.23 meters ultimately, with a speed of 1.5 meters per second. So speed is equals to distance over time. So time is distance over speed. Distance is 2037.23 and speed is 1.5 meters per second. This will give you answer as 1358 seconds. But since everything is given here in terms of minutes, so I would be saying answer will be 22.6 minutes. So ultimately he will take 22 point, or you can say he took 22.6 minutes to walk, ultimately coming back to its initial position. So these were basically the questions, and since I'm running the 21 days free GCSE crash course, so this is the reason I'm not putting too many questions in the worksheets, as we don't have much time. So these questions will be more than enough to give you a better idea, so that you can easily go and calculate and do the questions in the exam. And I can assure you, if you have seen my video, if you have done these 8 questions, it will be more than enough. So just before the exam, go through this one, and don't just do like this, okay, you have seen the video and that's for, like, okay, No, maths is all about the practice. You have to do practice on your own as well. That means, say for example, you have seen this whole video, but after you're done with this video, you yourself have to do all the questions without looking into the solution. Okay, once you are like stuck somewhere, you can refer this video, but you have to do it yourself, because when you look into the video, it seems very easy, everything. Okay, I'll do like this, but when it comes to do it actually, is a whole different thing, trust me. So that's it for today. Thank you and have a great day.